This is video 2 for homework problems for Math 241 to get you ready for test number 2. So we did chapters 3 and 4, and so let's talk about the homework in chapter 5. So in 5.2, let's look at problem number 2. Okay, so on the homework sheet, okay, I'm looking at the problem. So 5.2 number 2, if you read the problem at home, right, you want to assume you select a number at random from the interval -1, 2. And you assume the nature of the experiment ensures that if subintervals I1 and I2 of that are of equal lengths, the probability number selected is the same for both intervals. X is the value of the number selected. In that interval from -1 to 2. And it says use the method of example 5.1 to find the probability density function of f(x). So f of x is the probability density function, the PDF of x, and that's going to equal, well, the length of this interval from -1 to 2 is 3, and so I'm going to say that the probability is 1/3 if x is anywhere in that interval, if x is strictly between -1 and 2, and the probability is 0 elsewhere. That's the PDF for f of x. Okay, so the probability density function here is the probability of getting a value of x to be strictly between -1 and 2 is 1/3, because the length of that interval is 3, and then it's 0 for any other value of x. Okay, so that's number 2 in 5.2. Okay, so the next one is 5.3. So the next one's 5.4. Okay, so in 5.4, let's look at number 1. Let's look at number 1 in 5.4. So number 1 in 5.4, x is a continuous random variable. And its PDF function, f of x, is given to be this. It's going to be 2/3 x for x strictly between 1 and 2. And it's going to be 0 elsewhere. And we're going to find a few probabilities. So let's find the probability. That x is less than or equal to 1.2. Right? This is a continuous random variable. So the probability x is less than or equal to 1.2 is equal to the integral from 1 to 1.2 of 2/3 x dx. Okay? You're just taking the definite integral of f of x from -∞ to 1.2, but it's 0 when it's less than 1. So you just go from 1 to 1.2. And you find antiderivative of this, and that's 1/3 x squared. Okay? And you evaluate from 1 to 1.2 using the fundamental theorem of calculus. And so you get 1.44 over 3 minus 1/3. And so the answer is 0.44 over 3. Okay? Yeah, okay, good. And then you could plug that into a calculator, and you would get about 0.147. Okay, rounded to nearest thousand. Yeah, that's rounded up, okay? So it's rounded up to nearest thousand, 0.1147. Okay, so that's the probability x is less than or equal to 1.2, and I'll just do one more. The probability, there's a few of them here. Let's do the probability that 1.2 is less than or equal to x, less than or equal to 1.6. Okay, that's the definite integral from 1.2 to 1.6 of f of x, which is 2/3 x dx. So that's 1/3 x squared, evaluated from 1.2 to 1.6. And that's equal to 1.6 squared divided by 3, which is 1.96 divided by 3, minus 1.44 divided by 3. And so if you can do 16 squared and 12 squared, you can just put the decimal point where it needs to be, and you don't need a calculator. This is 0.52 over 3. And so that's the same as 0.17, that's 51, and then 0.173 rounded to the nearest thousand. Okay? And so that's the probability x is between 1.2 and 1.6 inclusive, including the endpoints. Okay, 0.173. Okay, so that's 5.4 number 1, 2 parts there. And now let's continue to the other one. And so now 5.4 we just did. 5.5. So for 5.5, let's look at number 2. Okay, so 5.5 number 2. And so for 5.5 number 2, we're going to let capital F of x equal to 0 for x less or equal to 0. X squared for 0 less than x less than 1. Okay, for that. And so this is the cumulative distribution function, okay, of our random variable x, our continuous random variable x. Okay? We want to find the probability that x is less or equal to 1. Less or equal to negative 1. So probably x is less or equal to negative 1, that's just capital F of negative 1. That's the meaning of the cumulative distribution function, right? The cumulative distribution function, capital F of x, is the probability that your continuous random variable x is less or equal to little x. So capital F of little x is equal to the probability that capital X is less or equal to little x. And so the probability that capital X is less or equal to negative 1 is capital F of negative 1. And the value of capital F at negative 1 is 0. So that's the probability. And now let's just do another one. Probability that x is greater than 0.4. Well, the probability that x is greater than 0.4 is equal to 1 minus the probability that x is less than or equal to 0.4. Okay? And that's equal to 1 minus capital F of 0.4. And so that's equal to 1 minus capital F of 0.4. It's 0.4 squared. That's equal to 1 minus 0.16, which is 0.84. And so probably x is greater than 4 is 0.84. Okay, so that's the probability x is greater than 4. Okay, and then the probability that 0.2 is less than x, less than or equal to 0.5, is equal to the probability that x is less than or equal to 0.5 minus the probability that x is less than or equal to 0.2. Because we want to know the likelihood of x being less than or equal to 0.5 and not less than or equal to 0.2. So that's capital F of 0.5 minus capital F of 0.2. And so that's both in that interval there. And so you just square those numbers. So it's 0.5 squared minus 0.2 squared. And so then that's equal to 0.25 minus 0.04. That's 0.21. Okay, so 0.5 squared minus 0.2 squared is 0.25 minus 0.04, which is 0.21. And so that's the probability for that one. Okay, so that's 5.5. Number 2. Now 5.6. So 5.6 number. Okay, so then 5.6 number 10. So for number 10 and 5.6, we have the cumulative distribution function of a continuous random variable x. It's capital F of x, and it's equal to 0 for x less than 3. And it's 1 minus k over x squared for x greater than or equal to 3. Okay, that's our cumulative distribution function. And so part A is find k. Find the value of k. Okay, well, in order to find k, we have to know that, first think about the fact that Okay, so in order to find k, let's realize the definition from negative infinity to infinity of little f of x dx is has to equal 1. Right? Oh, I got it. Sorry. Okay. So capital F of 3, right, is the probability that x is less or equal to 3. But it's 0 for x less than 3, and even if x is equal to 3, that's not enough to make any kind of... This probability is equal to 0. We know the probability of x less or equal to 3 is 0 from the given. And so capital F of 3 is 0. But 3 is a value where you get that value. So capital F of 3, according to the definition of capital F, is 1 minus k over 3 squared, which we know is 0. And so that implies that 1 is equal to k over 9. And that implies that k equals 9. And so the value of k is 9. So I found k. Okay? So we know capital F at 3 is 0. Because the probability is 0, cumulatively 0 up to 3 and including 3. And so we know capital F of 3 is 0. And we solve for k, it's 9. That's A. And then it says B, sketch the graph of capital F. And so the graph of capital F is this. When x is less than 3, the value of the graph is 0. Okay? And when x is equal to 3, we start the graph 1 minus 9 over x squared. So 9 over x squared is going to look kind of like this. So here's the value of 1. And it's just going to start it's going to look, I think, something like this. Okay? Just negative. Okay? And so it'll look like something like that. So that'll be y equals capital F of x. And that's part B. Okay, the asymptote will be y equals 1. So as x approaches infinity, it's going to approach the y value of 1. It's going to start here. And move there. So that's B. Okay, and then let's do C quickly. And so for part C, we have find a probability x takes in a value less than 4. Let's just do probability x is between 4 and 5. Okay, so the probability x is between 4 and 5 is the probability that x is less than 5 and it's not less than or equal to 4. But this is the same as probability x is less than or equal to 5 minus the probability x is less than or equal to 4. And so this is capital F of 5 minus capital F of 4. And so remember k is 9. And so then this is now 9 over x squared. And so now capital F of 5, you just plug in and you get 1 minus 9 over 5 squared minus 1 minus 9 over 4 squared. And then so then that's equal to 16 over 25 minus 7 over 16. And then when you combine those, you get 64. So then you combine those and you get 16 over 25 minus 7 over 16. And then 400. Common denominator 400. And so then that's 16, 196 minus 175 over 400. That would be the same as 21 over 400. Okay? And as a decimal, that would be 0.050, that's over 400, 21 over 400, which would be 5.0525. Okay, so probably x is strictly between 4 and 5 is 0.0525. Okay, because 21 over 400 is the same as 5.25 over 100, which is 0.0525. Okay, so that probably is 0.0525. And okay, so that's 5.6, number 10. And then 5.7. Okay, 5.7. And then, so then 5.7, so for 5.7, let's look. Okay, let's do number 8, 5.7, number 8. So 5.7, number 8 on page 172, x is a standard normal random variable. Okay, find the probability x takes on these values. So for part A, find the probability that x is less than 1.5. Okay, so the probability that x is less than 1.5 is the probability that x is less than or equal to 0, plus the probability that x is strictly between 0 and 1.5. Okay? And so probability x is less than or equal to 0 is 1/2, plus the probability that x is strictly between 0 and 1.5. Okay? And so you just look at the table in the back of the book for that. Okay, so for 1.5, it's 0.4332. This is 0.5 plus 0.4332. This is table 3 on page 561, table 3. It tells you the values of the probability that 0 is less than capital Z, less than little z, where this is the standard normal distribution. Okay, and so in this case, z is 1.5. And so you just look up 1.5 for the value of z, and 0.00, you get 0.4332. This is 0.9332 as the answer. Okay, now also let's do c, which is the probability that x is between 1.5 and 2.14. And so that's the probability that x is less than or equal to 0, plus the probability is between 0 and 2.14 minus the probability is between 0 and 1.5. Okay, and so that's equal to 1/2 plus this probability, which is 2.4, and so that table says it's 0.4918, minus the probability it's up to 1.5, which is again 0.4332. And so you add all those up, that's 0.4918. right? So in order to be strictly between 1.5 and 2.14, it's less than or equal, so it's, sorry, it's just the probability, it's between 0 and 2.14, and it's not between 0 and 1.5. So 2.14 is 0.4838. 0.4838 minus 0.4332. So it has to be between 0 and 2.14 and not between 0 and 1.5. And so then that you subtract those two values and you get 0.0506. Okay, and so that's the answer. And so you use the table in page 561, table 3, to find values of the probabilities for the standard normal variable. If a test requires you to know values on this table, it'll be provided, what you need will be provided for you on the test for values such as this that you would refer normally to the book for. Okay? And so these are all, we went through now all the homework in chapter 5, and the previous video went over 3 and 4. Okay? And so if you have questions, you can ask me an email or come to office hour and ask them there. Okay, bye.